go ahead and get started. Good morning, everyone, again, and welcome to our session, Continuous Testing for CTOs with Rainforest QA and Zenefits. My name is Krista Muir, Demand Gen Marketing Manager with Rainforest. Before I introduce our speakers, I'd like to do some quick housekeeping. Throughout our discussion today, please submit your questions in the lower left-hand box of the console. We'll have about 15 minutes or so for our speakers to answer them at the end of the presentation. We're also recording the session, and we will send that to you later today along with the slides. So to get started, QA testing is often a bottleneck to practicing true continuous deployment, but with new strategies around continuous testing, you can keep your growing organization's QA costs down and empower your team to test more effectively. And so today we are excited to introduce Laks Srini, CTO of Zenefits, to talk about their approach to continuous testing and how it got them to be able to deploy 3 times a day or more. And Russell Smith, CTO of Rainforest, to discuss some of the challenges with testing today and the strategies you need in your deployment pipeline to ship faster. So with that, Russ, let's go ahead and get started.
Hey, thanks. Thanks, Kirsta. Sorry about the slow start for this. I don't know what happened, but we're on air now. So I'm joined by Laks. I've known Laks for quite a while now. They've been early customers of Rainforest since they're around 18 people total, I think. Now today they're well over 1,000 and they're still using us well. So let's move on to the next slide and run through the agenda for today. So we're going to cover a few things. So why do continuous testing a tool? Like, what is it? A bunch of different types of testing we'll run you through and what use they are and where we think they fit in your development flow. And then how do you integrate testing into a development workflow? And then, like, the interesting one is going to be digging into how Zenefits do this today. Because they, at least for us, have more engineers than we do at Rainforest, and they may have more engineers than some of you listening now. So hearing their journey from a handful of engineers to several hundred engineers and how this fits is going to be an interesting one. Okay, so next slide. And so the challenges of testing today. Everybody who ships software today will know that shipping broken products is a pain. Like, customers don't like it. So there's the common challenges are manual testing. It's really easy to do, but it's slow. It's difficult to integrate into a continuous integration pipeline because it's humans. It takes a lot of physical manpower to do. So it's just not a great option. Automated testing is another option, which is really fast, but is expensive to actually start doing because you need physical humans, engineers to write the test for you. Also, once you've written the test, it's generally relatively brittle. So understanding whether a test actually failed because the test is out of date or the test actually failed because the test failed is a difficult one to do. So in-house QA, either QA or QE, so whether they're automating or not, generally overworks. Like, they never have enough time to finish their job. So this is one of the things that Rainforest helps with, at least, is removing some of the work of making tests and also executing tests from your internal staff. So let's move on to the next slide and talk a little more about continuous testing. So if nobody's heard of this before, it's the principle of testing your software as often as possible and definitely before you release it. So generally this includes running unit tests, running any kind of automation test you have, or testing your software with humans. The aim of it is to ship your code faster and give your customers better quality releases. Now, we believe that you get more value out of it the more you shift left. And by shift left, we mean shift towards the developer. So the right side of this being when it's in the customer's hands. The left being when the developer is actually actively working on it. So Rainforest at the moment operates on the right-hand side and is shifting down to the left. Some of the tools that you will be used to using, so unit tests, generally sit all the way along here. So like unit tests are run by the developer. They're run before you merge in a branch to your develop branch. They're run again by your continuous integration server repeatedly. UI tests are generally not run by developers repeatedly. So from the companies we've spoken to, only about 50% of them today use continuous testing. So most of them are not doing much testing, if any testing at all, but they're still deploying code to customers. And this obviously results in arguably less quality products being shipped to customers. Okay, let's move on to the next slide. Okay, so how does continuous testing fit into a continuous delivery pipeline? If you don't know what a continuous delivery pipeline is, stepping back, it's the process of shipping code to somewhere, generally to production, after your continuous integration servers run and successfully run. So continuous integration server, stepping back one further, is a server which will automatically build your software and then automatically run any tests you may have and report back whether it passed or failed. So continuous delivery is the logical extension to that, which is ship the code if it's all passing, which means you're trusting your tests. And yeah, so Rainforest fits into this pipeline, as do most of the other tools. They give you more protection before you ship code to production without checking it by hand. In fact, Rainforest obviously does let you check it by hand, but just not all hands. So let's move on to the next stage. And this is just showing where we fit in, which is what I covered already. So let's move on again. So from our point of view, there are like the different stages that are very common in most people's development practices. So there's when the code is developed, so when it's being developed by a programmer and by product people before it's actually merged into main branch. Then we have something called staging, which is where it's basically tested in a near to live environment, and then there's production, which is when it's given to customers. So these are, from what we've spoken to our customers, these are the most common types of tests that are done in development. So usability testing is usually done internally by internal staff. Functional testing, so writing unit tests and things. Regression testing, generally not done super commonly unless people have automation. Automation allows you to have a large suite of tests that you can run locally, albeit slowly against all your regressions if you have. And then there's cross-browser testing, which people like to do, but is generally pretty hard to do locally. So because you end up needing to run multiple browsers yourself, which is painful. So let's move on to the next slide. Then staging, the most common things we see here are exploratory, which is something where you would ask your QA people to run through and try and break your site, basically, to find new bugs in your site and to basically write tests that catch them later. End-to-end testing is testing generally flows through things, so testing that it works with other systems. Usability is very common as well, testing things just before they go out, that they meet standards of design and usability for your customers. Functional, again, is the same thing from before. Regression is similar, but generally easier to run in staging because you'll generally have that not be a developer's laptop. Cross-browser testing, again, common use of this is with, if you're using automation, would be a provider like Source Labs or Browser Stack, very common good people that do cross-browser testing. Rainforest also does this, but powered by humans, not by automation today. And yeah, so let's move on to production and what we commonly see in production. So most of the people we've spoken to, the only things they do in production are sanity or smoke tests. So they'll send an engineer or a QA person to check a release just after it's done. and run through a couple of core flows, or the features that have just been shipped. Some people automate this. That actually seems to be less common. So yeah, that's the overview of what we see today. So let's move on to how do you actually begin this? So if you want to integrate continuous testing into your continuous integration flow, maybe you're already doing it today, but maybe you're not. So identifying your current testing process is probably the key, and understanding what it is. If you're using manual process, then integrating it into your current flow will be blocking. So if you're trying to do continuous delivery, you can't really do that in a true sense, because you'll build the software, then you'll have to ask your QAs to do the test, and then you'll ship it later. And that process is generally too long to be considered continuous delivery. So one of the things we found as a best practice is to incorporate smaller tests. So rather than having very long tests, to have more smaller tests. This seems to make a lot of people, even if you're using automation, it makes it easier to understand and also more granular to find failures. So it is easier to maintain, especially if you can make them modular, so you can build tests in blocks. So continuous integration, most of you, if you're not using continuous integration but you're writing tests, you should move to use continuous integration. This gives you the advantage of a consistent build and a consistent run of your tests, so that you can always tell whether things are correct or not before they're released, or more correct. So automation alone, our belief is, and our experience is from talking to people that use automation, so by automation we're talking about Selenium or equivalents, find it to be brittle. And by brittle we mean it will break easily if you do minor changes to sites. Writing code that doesn't break easily is possible, but much more complicated to do. And also we found it to be flaky. So by flaky we mean you may get intermittent failures. So the classic example of this is LinkedIn use a lot of automation, and they run their tests, all of their tests, 3 to 5 times, and they take the average of the runs, so as a pass or failure. So if they get 1 failure and then they get 2 passes, that counts as a pass. Now, obviously this isn't great, because A, it's rerunning the test repeatedly, and B, it's like maybe it was an actual failure. So just a side note, like Rainforest avoids a couple of those disadvantages of automation, so it's less brittle and less flaky. And the main reason it's less brittle is because you can write tests in plain English. So instead of having to specify specific elements to click on for an automated test, or specific bits of text, you can ask people to follow instructions, basically, as you would with an internal QA person. So that means less brittle. So Zenefits, for example, who Laks is on the line, obviously, was able to scale to over 10,000 customers without an in-house QA team by supplementing automation with Rainforest. So let's dig into that. So let's go on to the next slide. So Zenefits, Laks, your main challenge was to maintain your product quality whilst you're growing so fast. And you said to me there's no room for failure. So do you want to add some to that?
Yeah, absolutely. I think while we were growing very fast and we were deploying multiple times and adding more and more to our products, at the end of the day, we're also enterprise software. We can't, the software cannot really break. I mean, if it breaks, it's like people don't get paid on time or people don't get health insurance, and that's really, really bad. I like to tell our new hires that Zenefits is like plumbing, and nobody pats you on the back when plumbing works, but when plumbing breaks, shit literally hits the fan. So it's pretty bad. So we want to use every which way we can to make sure that the product quality is really high. And I believe software is inherently broken, so making it work is pretty hard, and you want to use every tool at your disposal to make it.
Yeah, it makes sense. So you use a mix of automation and Rainforest and unit tests.
We have like our testing looks like we have unit tests that run on every commit, and we have a bunch of what we call glue integration tests that kind of we've written internally. It's a framework that does more of the integration, but we run it on continuous integration suite as well. We use Circle to run our continuous integration. And then we deploy to staging, and we have a whole bunch of canary tests there as well as Rainforest QA tests. And while deploying from staging to production, we also have another whole bunch of Rainforest smoke tests that make sure that kick the wheels, check the tires, everything is okay before code goes into production. That's kind of like how our pipeline looks like.
Cool. It seems like a good mix of strategies. So, out of interest, how many engineers do you have that write the automation tests for the canary test?
Well, we have about 140 engineers that write full stack engineers that write like automation tests, because we believe that like every engineer should write tests as part of their product, and we actually have a rule that we don't consider a pull request complete unless it has tests.
Yeah, that's a key one for everyone listening, by the way, is if you don't enforce some kind of process around having tests, whatever tests they end up being, whether they're Rainforest or only automation or only unit testing, then you'll find that they slowly disappear or become bad from experience.
Yeah, and other really, really useful thing to think about tests is that tests are, especially like integration tests and continuous integration tests, are a really great way to enforce or codify institutional knowledge. Because if institutional knowledge is in people's heads, like it's not really very institutional or very useful. But if it's actually codified and like automated, it becomes really, really useful. So we also enforce a lot of things in terms of security-related stuff or performance-related stuff, or even sometimes like we have like lint checkers or abstract syntax notation checkers that are integrated with our continuous testing. That just makes it harder for people to do the wrong thing.
Cool. Okay, Laks, I think we should move on to the next question. So I had a question for you, which is, why did Zenefits approach the continuous testing model at all? Like when you started this very early, right?
Yeah, I think because it's the only way. In more seriousness, I think like I have worked in places before where we switched from a completely just test before deploy long release cycle model to continuous testing, continuous deploy every week kind of a model. And it was night and day in terms of ease of development. So I think like code is like a living and breathing organism, and like continuous testing is like what is like oxygen to it, and it kind of makes it work really well. And also with continuous testing, continuous delivery becomes possible. If you have deploys that are too far apart, it's harder to make sure that everything is always going to work because like the delta of changes is too much.
Yeah, for me, I totally agree. The reason why for me is the risk. The amount of risk builds up the longer you leave it between releases, because you have more and more things shipping that could break. So that's why I really love the continuous. Especially for us. Like I mean, last year we went from 45 engineers to nearly 200 engineers today. And when there are so many people writing code, it's really important that like you have good gates and as well as like you ship very, very small deltas to keep the risk low. Yeah. And for you guys, like Rainforest itself is like 13 engineers. So there are times of the day when there's actually we're distributed, but I still think there's times of the day where there's probably no engineers actively working on code. But for you guys at 200 and you're distributed as well, like partially, there's probably no time of day when there's nobody writing code, right? So you've got to
we have 3 geographic locations as well. We have an office in Vancouver and we just opened an office in India. So we probably have round-the-clock development. I didn't think about it that way, but yes.
Yeah, I mean, I don't think it would be possible to do a traditional model with a distributed team, or if it did, it would be like a total freeze, which would be painful, right?
Yeah, absolutely. And the other great thing, I think, like that we've leveraged Rainforest a lot from day one is to kind of have Rainforest as a gate check and a gatekeeper before like we deploy code from staging to production. And that is really possible because of Rainforest QA being the distributed model that it is, because we deploy at 3 p.m., 3 a.m., 12 p.m., 12 a.m., and like all times of the day. And it is really hard, like if we had an internal person who was doing this to gatekeep and like gate check each of these deploys, they would literally have to be up like 24/7, and
Yeah,
that is not
so
like
that
very good.
it would be a huge amount of people. You'd arguably need like somewhere between half a QA engineer and 1.5 QA engineers per dev, right? And that is also a monumental job for hiring and managing them.
Yeah,
So,
absolutely. And then like the other thing is like not all deploys are same. There are like some destructive deploys and there are some very like small incremental deploys. So for example, when we have to do a database migration, like we usually like put those deploys at like 12 a.m. In the night so that like it doesn't really disrupt customers. So we have like an entire pipeline that kind of like does this as well.
Laks, so we just had a question, which is, so we had a couple of questions. One is we'll leave for later, but we'll get to. But one was kind of pertinent for this slide. So how many of your tests were automated versus in Rainforest? About 50-50, right?
Yeah, I think it would be 50-50. I think we for every automated test, we probably have a Rainforest equivalent as well, because I think it's really, really hard to do tests like, does this page look okay with automated testing? So I think like one of those things like where like we leverage Rainforest is like one, making sure like the page makes sense when people click through it and it actually like works. And we actually have like some tests like, does this page look weird? Which is like really useful because for a human to like perceive that and like say like yes or no really quickly, which like if you want to do it like via machines, like it turns out like it's not a super easy problem to solve. I know that like I think Google has like this massive pipeline where like they check like pixel to pixel of the last 20 deploys. We don't have that kind of tech yet.
Yeah, I've heard that's actually pretty useful. Well, I've seen one startup that's doing this in a useful way where it's not exactly pixel to pixel, but it's pretty, well, it's like smarter than that. It's like a human was looking at it. And that actually looks quite cool if you're doing like a layout sensitive site where it matters exactly. But I think at least most of the customers we're doing are more apps. I think Google used that for their front end like stuff. So the more, I guess ours are customer facing too, but it's more for user facing stuff, like mass user facing, I think.
Right.
But as far as I'm aware, it works for both. Okay, let's move on to the next question. So, Laks, you guys use something that you call hub and spoke model, which, as far as I'm aware, is unique to Zenefits. So I'd love to hear about, A, if you can run us through what it is, and B, any unique testing challenges that came up for that.
Yeah. I think to explain the hub and spoke model, like I would have to like go a little into like how we think about Zenefits as a business itself. I think the biggest problem with traditional HR systems is that you end up with like disparate systems that don't talk to each other. For example, you have a health insurance broker, you have a payroll system, you have a vacation tracking system, an expense management system, and so on and so forth. The bigger the company becomes, the more these kind of systems like people have. And whenever changes happen in the employee's life cycle, which they do happen when people get hired or like they get let go or they move houses, they get married, they have kids, they become managers, somebody would have to go and like update all of these systems like independently. And like one, I don't think that's the best idea in the world. It's 2016. And two, I don't think like the person doing that really enjoys their job. So if the world made any sense at all, you would have a single source of truth where you can go and change the data and like it updates and flows everywhere. And that's what we think of Zenefits as, like it's the single source of truth, but it's also this meta connectivity layer that pulls these disparate systems and connects them together. So if you look at it top down, it looks like a hub and spoke model. It almost looks like a wheel. So we have Zenefits, the hub in the middle, and you have health insurance, payroll, 401k, commuter benefits, FSA, vacation tracking, time and attendance, onboarding, offboarding, background checks, and all of these are spokes that connect onto the hub. The challenge with this is that it, like, if you think about it from a computer sciencey point of view, whenever you update data, it needs to like replicate to all the spokes. So this is almost like a giant distributed database. And the problem though is that like it's pretty hard to build a distributed database when you own all the nodes and the network. But we don't own all the nodes. Like these are health insurance providers and payroll companies and benefits providers. And sometimes there's no network. Like these companies haven't sometimes heard of what a REST API is. So you would have to use imaginative techniques to kind of connect with them and make sure you have fault tolerance, data integrity, eventual consistency. But the advantages with like the hub and spoke model is also that like it lets us organize teams in a fashion that's very similar to the hub and spoke. Because if you think about it, 401k has nothing to do with PTO, vacation tracking has got nothing to do with, say, commuter benefits. So each of these teams can like operate independently, and this what we organize teams into what we call pods, and like each pod mirrors a spoke. So it's a real challenge in terms of like how do you make sure it's great, like it lets people make decisions in local maxima and kind of move really fast in terms of their product itself, because they can make decisions and they can kind of like do stuff independently and there's no like centralized bottleneck. At the same time, what makes this hard is like when you look at it as like a service oriented architecture, it just the integration is the most important thing. So like we were a giant monolith application, and like we still are in some respects, but we are moving towards a more microservices world where each of these teams can independently deploy and operate, wherein like the complexity becomes that like.
Can I jump in and ask a question there?
Yeah.
So with the teams that run the pods, that run each spoke, basically, do you have a central enforcement of testing practices or deployment tools? How does that look? Are they all using the same pipeline and practices?
Yeah. So yes, we do have a central pipeline and like central policies and central testing practices. For example, one of the things is that, listen, like you will never make a pull request without a test. So that's like number one, that's enforced everywhere. And number two, it's like everybody uses a centralized pipeline for Circle CI that goes through Circle CI, that goes through staging. And we do have a single deployment cycle today because there are advantages with that kind of a setup, because you have lesser moving parts. So it's like a little more predictable than if you had like multiple moving parts. But in a microservices world where like we do have like a few services in the periphery that's moved out, we have a centralized programmable infrastructure system called Duplo that essentially lets you have standardized containers with like the monitoring, the logging, the web application framework, the firewall, and all of that stuff baked in. So all of these containers look very similar, although they're running like different applications.
Cool, that makes sense. I get why you do the centralized stuff, and I think that's smart because it means that there's a consistent baseline or a bar that must be crossed in order to ship stuff, which is smart, right? Centrally, you've decided that you must do some kind of testing with each pull request, and that is a good thing, I believe. So, okay, I think we should probably move on to, I'm aware we're running close to the end of this, so let's move on to scalability. So you guys obviously grew like crazy fast, at least So like it feels like Rainforest is going pretty fast, but you guys at some point I remember talking to you and you're hiring like 30 engineers a month, and like for you that must have been like there must have been some unique challenges with that, and so I'd love to hear about them, and obviously especially about testing.
Yeah. Yeah, absolutely. I think like it was more like 15 engineers a month. But I mean, that's not to say like that's not really hard. I think the biggest problem with us, like as we grew, was the continuous integration suite became bigger and bigger, and which is primarily like consists of like automation and some of the integration testing, and it started taking longer and longer for every engineer to get feedback whenever they committed code, and that's really bad because like when you have like 150 people like waiting for an hour for their continuous integration to finish, it just doesn't make sense. It's almost like you needn't even have continuous testing because the productivity is so low. But like one of the things that we've done is we've kind of split it into buckets, like much like what you've described earlier, where like you run unit tests first and get faster feedback loop, and then you run like the UI integration test in a second cycle and get a slightly slower feedback loop, and so on and so forth. But one thing that was kind of like very counterintuitive and eye-opening is that like the Rainforest says during the same time, the time was almost constant, regardless of the number of tests that you add. So you would think that automated testing can scale better than manual testing. So I think that was a really, really interesting.
It's a weird.
Kind of
that's a weird one, and it's kind of cool how that works from our point of view. And like
I think you should talk about it. I think it's like really interesting.
So like for everyone listening, Laks is talking about if you have a set of automated tests and you want to run like them, when your automation test suite grows, eventually you'll hit a wall and it'll start taking longer. You won't be able to parallelize it enough, partly due to expense, partly due to it's really complicated to get right. And with Rainforest, against automation, it can be slower for a very small amount of tests. But as you start getting a suite larger and larger, one of the powers of Rainforest is we can, instead of doing parallelization to like 60 or 100 different browsers at once, we can do like 1,000 or 2,000 testers all at once. So at some point, the fact that it's a human doing it who will be slightly slower than automation because they physically are running through your interface, we can still be faster overall because we can parallelize like crazy. So that's an interesting and not necessarily obvious fact about Rainforest.
And the other thing about scalability is that I think like because Rainforest tests are literally English scripts for people to follow, anybody can write these scripts. So we have a lot of like PMs writing Rainforest tests. We have like folks that are in the operations team like writing Rainforest tests, and it's really great that way too in terms of scalability.
Yeah, that's a good point. So like stepping on that train, when you said earlier your engineers learn to write their own automation tests as well, and like that's I get why you do, but that must have some overhead to actually learning it, which is obviously less in Rainforest, but there's a trade-off, right?
Yeah, absolutely. I think tests should be treated as like first-class code. And you cannot treat it as like this bastard child like that, like you just do later. I think it's really important that like people need to treat testing as first-class code. For example, we have a lot of seeders that we use like both for Rainforest tests as well as our unit tests, and there can be a lot of code sharing like when you do that. But it's really important to like drive it into culturally thinking about like tests as like first-class products.
Yeah, I totally agree with you. And I love the code reuse stuff. We find a lot of customers actually reuse stuff from their unit tests as well with Rainforest to generate seeded data. This rolls on nicely to focus on products, which is actually, like, for me, something I've become really passionate about. Is basically I believe that you should test your product, but I also believe you have to build your product. And for me, Rainforest gives back focus on people building product because arguably, and from what we see, it takes a lot less time to run and maintain compared to equivalents. So yeah, I'd love to hear your thoughts on focus.
I think it's definitely a great point. Focus is really important, and especially if you're growing really fast and like you have to keep delivering all these products and continuously improving them. I think it's really cool to have engineers focus on the product while the product managers can like make sure you have like all the Rainforest tests, and they do functional testing as well to make sure like everything is good like before launch. But it really is great that they can write all the Rainforest tests for their product, and we have regression tests and we get smoke tests and we get all these niceties automatically.
Yeah, it's pretty cool. So there's another question from Abdul, which is related. So he asks, after writing automation tests, including Rainforest tests, how, so I'm guessing this is directed at you and me, so we'll both answer it. How do you maintain tests for a long period of time, especially as feature functionality keeps changing? At least, so Abdul, at least for Rainforest itself, we will see the test fail, and then we'll go in and fix it, is one way. And the other way is when a feature, so that's when we don't expect it to fail, but it does for some reason because we update something and it breaks. If we expect it to break, then we will update it beforehand. And that's generally done by the developer. So yeah, the developer writing the
it works. Yeah, it works the same way at Zenefits as well. Like the automation test would break if it changes. And I mean, like we espouse this theory that like tests are the lazy engineer's best friend, and some of the best engineers I know are also the laziest people. I think it's a good attribute. So if you own a product and it breaks, it's your responsibility to fix it. But if you own a product, you had tests, and somebody else broke your tests, it's their responsibility to fix it. So it's in the vested interest of every engineer to have like good coverage for their product. Let's leave alone that you don't want to be woken up at 3 a.m.
So another question from Joe, which actually is quite a cool one. He's curious what your QA teams look like, more QA, less QA. I'm going to jump on that first. Rainforest itself actually has no QA or QE people at all. We exclusively use Rainforest for this. Laks, what's yours look like?
Yeah, for us, we expect every engineer to write their own tests. But we do have the infrastructure team have a couple of like engineers focused on quality and test frameworks and maintaining our test framework, making it better, making it easier, and also maintaining our continuous integration infrastructure so that tests are run faster and a whole bunch of stuff. That's where the focus is on, like from a quality architect or an infrastructure person. But every engineer writes their own tests. So we do not have QA folks manually testing. We do not have SDETs that are writing tests for engineers. But we do have like quality engineers and quality architects that maintain the test infrastructure.
Okay, that's cool. So Kate asks, I guess you just answered this actually, but she asks if you're still doing manual or automated testing. Obviously, it depends how you fit Rainforest into that. You are doing no in-house manual. You're using Rainforest.
Yeah, we're doing no in-house manual, but we do have like some canary tests that run almost on smoke tests that run on our staging environment, which are built of Selenium drivers and other like the other in-house technologies.
Yes. That makes sense.
But like we use Rainforest for manual testing.
Okay, so Kate, just to be clear, it depends on whether you, or to everyone actually, it depends on, Rainforest is powered by humans, but it's not really manual, that makes sense, because nobody in your org would be doing it themselves. Okay, let's move on to the next slide, which I think is the last slide before we take more open questions. This is like, we'd love to hear some of your aha moments that you had around continuous testing in any form, like when you realized it was good to mix them up, when you realized Rainforest was going to be the thing. Any of the things on this slide would be great to hear from you, Laks.
Yeah, I think one of the things that we almost didn't believe was when we first heard about like how Rainforest worked, is that you could have like people testing your product and you could get the results back in a transactional API. And it's almost like the best of both worlds. You could have like hybrid automated manual testing, which was like great. And I think that's kind of like where we began using Rainforest, I think back when we were 4 or 5 engineers. And since then, it's been like really great. And I think like the little bit of work that, and thanks Russ like for helping us like with integrating firing off Rainforest tests from within our continuous integration suite. I think that was also really cool because the more you can enforce these things within your development pipeline or development processes, the more the chance that this actually works. So I think that was another thing, that if you don't have policies that enforce but like just say stuff, it doesn't really work. I completely agree about the brittle/flaky part of the automated tests. We do something similar to what you described how LinkedIn does it. We retry a lot of these tests and then take an average of the runs. I think all of these were like really good learnings like for us.
Cool. So unless we have any more things to chat through, I think we're pretty much out of time. There's a couple of questions left over that we didn't answer yet, so I'm going to just scroll back up and go through those. So Nicholas asks, let me just retranslate this a little. Nicholas asks, how do you do releases when you have database updates that impact your customers? Like for us at least, when we do that, either the updates are so small, like they'll only lock something for a second or two, in which case for us that's totally acceptable. We just do it. If the update is going to be down, like mean something's going to be broken for like a longer period of time, we generally turn it into what's called a zero downtime migration, which basically is just a more complicated way of doing the same thing. So for instance, instead of there's a whole blog post on this that I'll link in the chat. Basically, it's kind of a big subject, and it's complicated to do right.
Yeah, I think for us, like we break it down into destructive DB updates and DB updates that are just incremental and like doesn't really cost anything to break. We have certain policies around like destructive updates. In terms of enforcing the processes to do it. For example, you never drop a column, you rename it, and a whole bunch of stuff. And we have automated enforcers that actually enforce that, like, this, if you drop a column, it wouldn't work. We use Django, and like we have like custom code built into Django migrations to kind of like enforce these things. But when there is a destructive update that needs to go out, we generally do that deploy as part of the midnight deploy.
Okay. For everybody else, I linked a blog post that we wrote a while ago, actually, that details how we do zero downtime migrations. So you can sometimes, like not all of the time, do the destructive updates that Laks is talking about in a way that you can still do without downtime, but it just generally means much more effort from the engineering side. So sometimes it's not worth that trade-off. Okay, so I think there's another question. Hang on, I'm going to try and do these in order to be fair to everybody. So hang on, oops. So did you have any trouble or do anything interesting to motivate your engineers to write their own tests in addition to getting their development work done? For us, Neil, No, we didn't have to. Basically, we want to dog food our own product. So we actually can't deploy Rainforest, a new version of Rainforest, unless it passes Rainforest. So we call that extreme dog fooding because we literally cannot deploy a new version until the test pass. And I believe that's really important, and so do all the engineers here. And the reason why is, for us, we're a testing platform. We can't have crappy quality code. We can't not test it. We also can't not make sure our product is good. So we really strongly believe in testing at Rainforest.
Yeah, I mean, it's very similar to us as well. And like I said a little while ago, we truly treat it as it's the engineer's best friend. If you have complete test coverage of your product, it wouldn't really break, and you wouldn't be woken up to fix it.
Cool. So we have one last question, and then we're going to wrap up for today. So Abdul asks, how can you make sure you have sufficient test coverage? If product devs are writing tests, that must be pretty difficult to do. So for us, that's actually a good question. For unit tests and stuff, we have tools that give coverage of the product and tell us how much we've done. We don't actually have an equivalent for that for Rainforest. So the only way we can do it, the only way we do it is by enforcing new features to have tests, but we don't have any metrics on coverage itself. I guess the other thing to drop in on that, Abdul, is that coverage can be a misleading metric to look at. You can have 10 crappy tests that give you 100% coverage but don't actually test anything properly. You can have one test that tests things in detail and doesn't cover everything, and it can still be very valuable. But yeah, we don't have a solution for that at Rainforest. So, Laks might, though.
Yeah, we do something very similar for our entire automated and continuous integration suite. We have code coverage metrics, and there's a report that's published with every single automated run that we do. We're also thinking of having a line in the sand that says you cannot get code quality coverage to less than a certain percentage, and we would probably fail your tests. We're actually working on it actively as I speak.
Cool. If you're ever going to open source any of that stuff, let us know, and we'll tweet it out too. So, Laks, thanks so much for joining us today. It was really fun talking to you. Everybody else, thanks so much for listening to us. If you have more questions that we didn't answer, feel free to go to Rainforest QA and ask on Intercom. So there's a little button on the bottom right. You can ask us, and one of our teammates will get back to you with the answer. If not, you can always tweet at us, and we'll try and answer on there too. So we'll be doing another one of these soon, not with Laks, but with somebody else that's really interesting too. So please watch this space, and see you soon. Bye.
Thank you, Russ. Thank you, everybody.